My name is Marcus Bulstrode and I work for the Queensland Department of Agriculture and Fisheries. I'm working with growers to better understand their farm, taking it from managing the farm as a big single unit to reducing it down and managing it as separate small management units. This could be an area of just a few square metres, or it might be an area of a few hundred metres. It's a very exciting time to be in agriculture. New technologies such as drones are providing a whole range of new tools for us to be able to better manage farms. What we actually do with the drone, we'll put the drone up in the air, we'll fly over the crop, that might be at 100 metres or so. The drone is looking down the whole time with its sensor and it's basically taking high resolution images of the crop. Drones come with a range of sensors these days. The typical one that I would use would be just an RGB, a red, green, blue sensor, so if you like a standard camera. But we also have multispectral cameras and thermal cameras. So we have some very specific sensors that we can tune to identify the character that we're interested in. I then go back to the office and I can process those images and start to unlock where the areas of difference are across the paddock. I've stitched together all of the images and now I have a single orthomosaic high resolution image of the paddock. If we look over here where there is no vegetation, we actually can't really see much going on at all. What we need is what we have here, where we've got a crop. Suddenly we can see all sorts of variability, and it's the crop that actually shows us the difference in the growing conditions, and that's a very important aspect of it. Ideally, the crop needs to be a bit over 1 metre high. I need to get enough leaf matter to be able to be seen by the drone clearly above it. In some cases, it's much easier to visualise the problem that we have using a 3D model, but I can zoom in and have a look around to see, okay, what did it actually look like on the ground? What was the effect that the growing conditions were having on the cane? In a 3D perspective, it's actually very easy to see the difference in the growing conditions. I can see the area that I'm particularly interested in. If we look back up here, another area where it's doing very poorly compared to relatively even the rest of the block. So I can zoom right in on that area and have a much closer look to see, yep, that's very poor cane through here. There's all sorts of weeds that have dried off. That's the area that I want to be able to go back into that paddock and see what's going on. I can run it through a couple of different algorithms here, a colour-coded elevation model of the paddock, blue being low, red being high, and we can see that this strip where the cane is not doing well is lower and much more open. So this is exactly the sort of area that I would then go into the paddock and start trying to work out why, and can I actually change that zone to make it better for the sugarcane. What I can do is take a marker, put that marker into this image. That marker is now a geo-referenced point that I can go back to with another device such as an iPad. I can walk back into this paddock and stand at that precise point and know that I'm in the middle of the area that I'm concerned about and start to do some analysis to work out, okay, how can I fix it? And this is exactly the sort of thing that I would say to myself, I need to do some soil sampling, some testing of that area to see why is the cane not doing well. So using the drone mapping, I've been able to identify a part in the paddock where the cane was not doing well. I've extracted a soil core from this zone. I'll be able to analyse this soil core and start to understand what the limiting conditions may be for crop growth. Up here where the crop's growing, we've got roots, got organic matter, things that we need to have. We start to get a colour change as we come down through the soil profile. We've got now an absence of roots. There's nothing growing down into this part of the soil. And then when we get right down here, we've actually got, that's virtually beach sand. There's just nothing there at all. No clay, no organic matter, so not a good growing medium and something that would be needing to be treated to be able to grow cane properly. And in many cases, I should be able to improve this area to make the crop grow better. Remember that previously this paddock would be managed as one unit. It gets the same fertiliser, the same cultivation, everything is put on identically across the whole paddock. And yet we know that there's actually different growing zones. Some areas grow better cane, some areas grow poorer cane. Utilising the drone technology, we're able to target those areas of difference. We can then start to manage them separately. So for example, with this farm here, we're actually trialling some different techniques to improve the soil in those poor growing areas. We're going to actually add some organic matter and some clay and see whether we can increase the water holding capacity and also the nutrient holding capacity of these soils. The great thing with drone technology is it provides the base maps for other precision equipment. For example, variable rate fertiliser boxes, and what they require is relevant mapping products that can go into the tractor. We've got a smart implement on the back of the machine and it can alter its fertiliser rate within the paddock as it's going along. So the best outcome is for the crop to take up the nutrients that we're applying. We don't want nutrients leaving the paddock. The grower doesn't want nutrients leaving the paddock heading out to the Great Barrier Reef. We want the crop to use them and to grow a large crop. The same thing applies to weed management, that typically across a paddock we've got areas that produce more weeds and some areas that might produce fewer weeds. So if we're putting out herbicide, we might want to put it out particularly targeting those zones of high weed load. Whereas the areas that don't have weeds, we might say to ourselves, well, I don't need to put any herbicide out. There are significant efficiency gains for both the grower and also for the natural environment. The other great thing with the drone mapping is that we can compare it to other mapping systems. For example, EMI, which is electromagnetic induction, where we actually can measure the differences in the soil properties. We can now compare that to the crop yield above those soil differences and to see how well they match together. There are many uses for drone mapping for precision agriculture. One example here is flow mapping. We can actually create the surface water flow model for the land that we're interested in. So that means that we can design drainage networks, all sorts of other earthworks based around the drone mapping. In the near future, I think some of the biggest developments are going to be in AI, so artificial intelligence. For example, automated weed recognition, where I can fly the paddock, put the data set through an AI program, and it will automatically find the character that I'm interested in. It might be a particular weed, and it will identify how much of the weed is in the paddock and whereabouts it is located. The great thing with drone technology is that it is actually accessible to growers. The machines are quite advanced, quite technical, but they've reached the point that they're almost consumer level these days. So a grower can go out, buy a machine, get a bit of advice on what he may want to be doing with the mapping side of things, but basically a grower can go out and do his own crop mapping and then engage with an agronomist or an advisor to understand those different zones. I've been flying farms for about the last 5 years, and what has really struck me has been the amount of variability that there is across the growing regions. At first we used to think that farms were fairly even, but the drone mapping has revealed that most farms have a high level of variability. We just didn't know it before. We now have a tool where we can easily identify that variability and set about doing something about it.